the model 7.1 that we supposed to complete it last week, right? So you download that two files for our exercise today. The ASCII file for arena input analyzer named part PRP. If you open it, everyone got the file? Okay, this is the file we try on input analyzer. The extension of this file is not DST, but actually it can be any extension that that is ASCII file, like TXT is acceptable. So if you already have this file, then you can go to Arena and try the input analyzer. Okay, let me just try today. Okay, everyone got the file? Right, let's try it. Now we go to the tool. In the tool, you see, you look for the input analyzer. Tools, input analyzer. You choose it. Okay, and we have a completely different window of input analyzer. Okay, and we will choose new. Now we go to the file. We go to data file. Right. And choose use existing. Let's say we already created the data file somewhere and store it somewhere. So we choose use existing. Right. And then you look for the DST file that you just downloaded from Blackboard. Let's try this one. The part prp.dst. DST stands for distribution files in Arena. Okay, and now open it. Okay, immediately we will receive a histogram of this data. Okay, so the software automatically divides our data into 13 intervals. All right, now let's say we try to identify a distribution that fit our data. Okay. We go to fit, all right, and the input analyzer gives us a number of available distribution. We can choose any of them with the text. But let's say we are not so confident and want to try all of these. Try to all of these, then we will just fit all. All right, so let's try fit all. Everyone follow me? Do you follow me? Yeah, I'm doing too fast. Let me know. All right, I will do it even slower. Yeah, let me open the chat box to see if anyone want to say something. No, all right. Okay, so on the below window, you see is show us gamma distribution. Gamma distribution. Okay, so it's based on the distribution. As we request, we ask it to fit all, and the distribution that it proposed from the list is gamma, and it's also calculate for us if it is gamma distribution. These are the parameter estimation for gamma. Okay, so gamma have 3 parameters. So it gives us the parameter estimation for gamma here. Okay, so we no need to compute it. And it also gives us the hypothesis testing result. The chi-square test, you look at the p-value of the chi-square test and the p-value of the KS test. Both the p-values are quite high, right? It's larger than alpha 0.05. All right, so let's say if this is our critical value, this is alpha, then this would be our p-value. The p-value is larger than alpha, so we would accept the hypothesis. We would accept that the gamma distribution is quite suitable for our data. Right? But as I told you, the software doesn't know about the physical characteristics of our data. It's just based on the square error and the p-value, the largest p-value among the tests, and give us the suggestion. Right? So it may not be appropriate. So we should check other results from other distribution. So if you want to check the result from the fitting of other distribution, then you go to window. Okay, you can have a look at the fit all summary. And here this list on the square error. The square error is the difference between the true value and the predicted one. So it will list from the smallest square error result to the largest one. So you see that gamma is the top of the list. And that's why it suggested gamma. Okay. This is one window you can check. Another one, you can go to window, okay, and look at curve fit summary. You check for individual data. Let's say, let's look at again the fit on summary. We have gamma, Weibull, beta, Erlang, normal. And let's say the normal seems, the square root error of normal seems to be small as well, even though it is rank 4 in the list, but it's still small. So let's look at the normal for, sorry, let's check the normal alone. All right, and we go to normal. Right, and here is the details result for hypothesis testing of normal distribution. Okay, if the software fits normal distribution to our data, it also estimate the parameters for the normal distribution. And we get the mean, the estimated mean is 0.33. This is the estimated standard deviation. Okay, and the below is the chi-square test result. The p-value is 0.06. Okay, and if we do the k-step result, the p-value is quite large, larger than 0.115. Okay, let's try the chi-square test. The chi-square test here, the p-value is 0.06. If we choose alpha equal to 0.05, the p-value here is still larger than 0.05. So in the case that we think that normal distribution fit the physical characteristic of our data more than others, and because the p-value is still larger than alpha, then you still can choose normal distribution in this case. All right. Okay, so you can use input analyzer for your project from now when you do the data collection. Okay, class? Any question? Any question with the input analyzer? Okay, if not, then let's open the model 7.1 that I posted in Blackboard for you. Have you done your own at home? Do you have any question? Okay, so everyone, let's open model 7.1 from Blackboard. we'll check together to see whether you did at home correct or not. All right, it's okay now. You don't need to submit it on Blackboard, all right? Now, but let's say we try to start with the same level. So I posted the answer file for all of us to do it. Right. Okay, so let's just open that file. Everyone got it? Uyên, can you open the file?
Yes.
All right, good. Let's check one more student. Khánh.
Yes.
Can you open, you ready to open the file?
Yes, I can.
Okay, so let's check together. All right, so this is where we supposed to finish last time. Okay, now the highlight of this exercise is the station. Right. It's the station and route, like the pair of station and route. In between we have the process. And also how we dealing with the data processing. Okay. So last time we are talking about assigning the part index for the part according to the distribution. Right. And we assign the part sequence. We assign the part sequence for the attribute of the entity using the default attribute entity.sequence. So here we learn 3 default arena attribute. The first one is entity.sequence. The second one is entity.type. And the third one is entity.picture. These are the default one. So when we're dealing with more than one type of entity, then we very likely need to use a set. So for the sequence, we will use the advanced set to set the part sequence. For the entity type or the entity picture, let's go to the basic process and check the set. Right, we will have the set of the entity picture. We have the set of the entity type. Okay, and remember for cell 3, we have 2 resources, one old machine and one new machines. We also can create a set for the resource. The set data module allows us to create the set for resource or counter and tally if we want to, when we want to use the record module and record the data into a set, and the set the entity type picture. For the set of sequence, we'll use the advanced process and use the advanced set to define the set for the sequence. Okay, so the first one is about a set. Okay, pay attention on this one, how to use this set. When we have more than one characteristic, more than one values of an attribute or variable. Now, the second type is the variable. So previously we only define variable one value, but we also can use the variable in the form of an array to store many values. So in this example, what are the variable we have? So let's check the data. Let's go to the basic process and check the variable data module. Okay. Here we define a variable transfer time. This is the transfer time we use for our root module. For the root module here, we define root time. The value for the root time is transfer time. Okay. Well, we can put directly 2 minutes here, but as I told you, let's say when we later, if we want to try different root time, it's much more convenient if we define a variable for this. So let's say if we don't want 2 minutes, we want to set 5 minutes. Then instead of going into each root module and change from 2 to 5, here we have 1, 2, 3, 4, 5 root modules. So we have to change 5 times. But if we define the root time with a variable transfer time, then all we need to do is to go to the variable data module and change the initial value here from 2 to 5. It's quite convenient. So this is a skill that we do in any programming or in simulation. Try to define a variable so that we can change the value easily. Okay. Now the second variable is the factor. This one will be used when we dealing with the processing time of a new machine and the old machine in the cell tree process. Okay, so we will check that later, but just keep in mind here that we have a variable named factor, and it is an array. It has 2 rows. The first row, the value is 0.8, and the second value is 1. Okay, all right. Now, the third one, you also can take note in this model is the expression. Okay. Okay, recall that for this system, when the entity goes through different cells, it will have a different processing time. Okay, or for the same cell, for different part, the processing time is also different. So last time in the class, we can define the processing time. We can assign the processing time as an attribute of the entity in the sequence data module, right? Okay, so let's check the advanced transfer. And looking at the sequence, Okay, let's look at let's say the sequence for part 1. So the sequence for part 1 here shows us the root for part 1. Part 1 we go from cell 1, start from cell 1 to cell 2 to cell 3 to cell 4 and then to the exit system station. Each cell here we can assign a value for the processing time attribute of part 1. So we assign an attribute. The attribute name is the process time, and part 1 enters cell 2. The process time would be triangular 5, 8, 10. Or when part 1 enters cell 3, the attribute process time will take the value triangular 15, 20, 25. Right. So in let's say in cell 2 process module, in the expression, we just type the name of the attribute process time, and its value will change accordingly. Okay, so this is one way of doing this. Now another way that you may want to try by you can click on cell 1 process. Okay, click on cell 1 process and have a look. Now instead of putting the process time attribute in the expression, we also can define a variable, which means the processing time for cell 1. And that variables will have different value according to the part index. Okay, if part 1 enters cell 1 will have one value, part 2 have enter cell 1 will have another value, part 3 enter cell 1 will has another value. So both of them will have the name cell 1 time. Right. So here, if we want to try this way instead of using the process time, instead of using the process time in the expression, then what should we do? What should we define here? We try to use different ways, right? Either ways is okay. Just try to show different ways here. Now, if we want to define a variable that we change according to the part index, so what do you think? Which one should we use, the variable or the set? So a set we also can have many members in the set. The variables, you also can have many rows in the variable. In this case, because the processing time here is a distribution, it is a distribution, triangular something, right? If I remember correctly, the expression is a distribution. So if you use variable, it won't allow you to define a distribution in a variable. You can try it. Let's try it. Let's say I go to a variable. Where is it? Okay, basic process. I go to variable. Okay, and let's say I try to create a variable and its name is cell one time, for example. Okay, and I'll try to use 3 rows for it. Okay, and I will put 3 distribution for the cell one time according to the 3 types of our part. So the first one, let's say triangular, 1, 2, 3, for example. And if part 2 enter cell 1, it will follow triangular, 2, 3, 4. All right, this one will follow, let's say, triangular, 3, 4, 5. All right. Let's say I want to do this so that in the cell process, whether it is part 1, part 2, or part 3 enter it, it will take accordingly the distribution accordingly. But here you see that it has the yellow highlight here, which means that it doesn't allow you to do so. Okay, you cannot assign a distribution for variable here. It's okay if you enter a number like 2.3, 4, 5, or 6. It's okay. But a distribution is not allowed. So we cannot use the variable in this case. I delete this one. So for if we want to do this way, then you can use expression for distribution. Okay, now let's check the advanced process and look for expression data module. The expression data module allows us to define a distribution or define a certain equation, a certain formula in advance. So let's say if we want to use x1 plus x2 multiply 3 or so on, then we can define an expression here. So when we type the expression name, it will follow that distribution or that formula that we want. So let's say we will create an expression named cell 1 times that we will use in the cell 1 process. Okay, so and if you have 3 numbers or 3 rows in this one, we type in here 3. Okay. The expression values. Okay, here the cell 1 time has 3 rows. Each row has different distribution here. Now this time it's allowable. It doesn't like the variable one. Okay, so now we have expression named cell 1 times. It has 3 rows. Depends on the index we want, it will take the distribution of that row. Okay, so now let's go to the cell 1 process and check again. It will take the expression named cell 1 times, and the row 1, 2, or 3 depends on the part index. So each entity enter this process module will have a part index value. And depends on the part index value, it will take the distribution in the row of cell 1 time. Okay, that is another way to deal with the processing time for different part, different type of entity. Okay, any question? Do you follow me? Let me check if anyone got any questions so far? You have time to follow me, like follow me and try the software try the model in your computer. Right, if no questions, so let's try, let's check one more. Let's look at the cell tree. We have a special characteristic in cell tree. We have two machines. Okay, and we can use either machine. So if two machines are completely identical, then what we can do is just to use the normal resource like cell tree machine, and the quantity is 1, and in the capacity we define 2, right? But because the two machines have different characteristic, which is the processing time, so we will define a set. We type a set of resource, and it has two member, new machine and old machine. So when we define a set, the members of the set has different characteristics. It is the same category, but it has different value, different characteristics. Okay, so the two machines here, the same resource category that we will use in cell tree, but it has different processing time. So we will use set here. You set. We already created previously. The quantity is 1, right? Each entity only enter one machine. We can choose the rule here. It's up to you. We don't specific requirement here, but whatever the machine, the entity use, the part enter, we would like to save that information, the information of which machine it used, into the attribute of that entity, named machine index. It is similar to the call center model we did last time. You remember that one? Where the customer talked to a technician, and we'd like to save the name of the technician who talked to that customer in the attribute of that customer. So it's the same here. We'd like to save the machine 1 and machine 2. Let's say machine 1 is the new one and machine 2 is the old one, into the attribute of the entity, and that attribute name machine index. Okay, what for? Why do we need this one? Okay. We will cleverly use that information in the expression for the processing time in cell 3. Okay, so you see here we can use the variable array in a very clever way. We have the process time that we already assigned the value in the sequence. Okay, so like any part go to cell 3, we have a processing time. But let's say if this is the new machine, then we would like to have that process time multiplied for 80%. Means the processing time for the new machine is much shorter. It's only 80% of the old one. And if it's enter the old machine, then the processing time would multiply a factor with value 1. And the value of the factor, we already define it in the variable. Okay, remember, let's check again. In the basic process, in the variable, we have defined factor variables. This has 2 rows. The first row is 0.8. The second row is 1. So if the machine index is 1, it will take 0.8. If the machine index is 2, it will take the value 1. All right, and so we solve the problem. of assigning different processing time for the new machine and the old machine. And the way we do here is using variable with different variable with the array with many rows. Okay, so basically we already solved on the features of the system. Have you done like that at home? Unclear, class? Okay, now let's try a bit something more with the run setup. Okay, let's go to the run setup. Everyone go to the run setup. Right now, the run setup is set with 1 replications. The replication length is 32 hours. 32 hours is like 8 hours per day, so we have 4 days. Okay, run the simulation will run continuously 4 days. Right, we have 24 hours per day. Okay, so let's run it. You can look at the animation on the software while you run it. All right, we have 137 number out means the system parts, but we don't know it is part 1 or part 2 or part 3. Okay, so let's look at entity. Here you see the statistic for part 1, part 2, and part 3. The reasons that we are able to see the statistic for each part here is because previously in the assign module, right, we have defined the entity type. Let's, the entity, no, this is the attribute, the entity type. Okay, so we have entity type 1, 2, 3. We have a set of entity type. All right, and we already have defined entity type 1, type 2, and type 3. If you don't define the different entity type like this one, then we only have one type entity, that is entity 1. And in the report, it's only report to you the information of entity 1 in general. But because we already define different entity type, yeah, so in our report, we are able to see statistics of 3 types of entity. Let me go back to the report. Okay, and we have resource utilization. Okay, remember we only run one time here. And let's say to see if we have any user specified here. We don't have any user specified statistic here. Okay, now let's try to modify our model. Remember in the theory class, I told you that we shouldn't run our simulation only one time. Okay, it's quite random. We have to run with many replications and get the average to have a better estimate. So, so let's modify our model in the run setup. Okay, let's set the run length 5 days and 10 replication. Okay, run length 5 days and 10 replication. But before we do that, let's check the let's say the statistic for one replication, and then we will compare it later when we run many replications. Okay, so I will take note here. If you look at entity one, in is 143, out is 143, part 1, 36, out is 33, right? You can take note as well. Part 2, 62, 60, and part 3 is 45 and 44. Okay, let's check one more statistic like what else do we have for entity? Processes, let's say anything interesting in process. I didn't choose to collect the statistic for the process, so it's not important here, so it's okay. All right, now let's modify the model, modify the range setup. That's what I told you. 5 days and 10 duplication. Duplication is duplication 5 days. And also let's say we want to collect the WIP statistic in our model. Right? WIP is not a statistic that available in the default report of Arena. So if I want to collect the WIP statistic, what should I do? Anyone remember how to collect the WIP statistic? Let me share this screen. All right, okay, in the run setup, 10 replication, we set 10 replications here. The replication length is 5 days. Okay, right. How to collect the WIP in our system? The total WIP here include the WIP type 1, type 2, and type 3. Entity type 1, entity type 2, and type 3. Last time you learned a technique that you can manually count the whip, right? Like you create a count variable, a variable where you count an entity enter the system and then minus that variable when the entity out of the system, right? You can use that one, but you also can use the default arena variable names entities that we I think I also show you that one last time. This variable, let me type in here. The variable names n t these right, and inside the bracket is the name of the entity type that you want to collect the width information. If you want to know the width of entity type 1, then you type entity type 1 here, the name of the entity. Okay. Right. Now we want to look at the total width. So it would be entities width, open, bracket, entity type 1, right? And then plus entity width of entity type 2 plus entity width entity type 3. Okay. But you need to tell Arena that you need to collect this one in which model? Anyone remember? Width is a tally or a time persistent variable. Width is tally statistic or the average width is a tally statistic or time persistent statistic. Right. How do we calculate the average width? We will take the average over time, right? We don't take the average width over entity, so it will be time persistent. So if we want to collect time persistent statistic, we have to indicate it in the statistic data model. So let's go to the statistic data module in the advanced process. Everyone go to advanced process, statistic data module. Okay, I already have here, but you don't have, so you key in this one. Right, let's give our statistic a name like total width. All right, and it's a type of time persistent. Right, you choose time persistent. And in the expression, let's type the function entities width. This is a default function. Okay, in the bracket, type the name of the entity type. We already find the name part 1, part 2, part 3, so we put like this one. Right. So by doing this, we are asking Arena to take a time persistent statistic, the average one of the total width, part 1, part 2, and part 3. And okay, we also tell that we collect the statistic in time, the replication, and in the report, we want it show us a statistic in the report under the label name total width. All right, and for this one, output file, this is, you can put this information here. If you want Arena export the data for you, in an external file. In the report, in the renal report, we just have the average statistic. So what we want is just one number. But if we want to have all the data collected for the whole simulation, all right, so not just the average, and we want is export to us in an external file. Then you type the name of the file here. Okay, not name of the file here. You can indicate where's a folder. And let's name it total with history.dat. Then later we can go to that folder and open the data, and then you can like have a more thorough examination on the data instead just looking at the average. Right, I give you a few minutes to type in this one. And after that, you can run, right, and have a look at the report, see what we have in the report. All right, have you done? So let's run together. Let's run setup, time duplication. Duplication length is 5 days, 24 hours per day. Okay, let's run. Let's see the result. Okay, if you have a category overview, we see the result for 10 duplication. 10 duplication, the time delay is minute. All right, but here there's no summary statistics are available because we didn't choose, we didn't ask it in the run report just now. But anyway, we can look at, let's say, the user specified. Right. We have the user specified for each 10 duplication here. This is a total width. Right, we have the first duplication, the total width, the average total width is 11.45. The second, the 10 duplication, the average width is 10.77. Okay, so here the authentication. And go to the next page. And for the report, we see the average value, the minimum, the maximum, and the half-width value. Already, we just mentioned about the half-width of the confidence interval yesterday, right? How do we calculate the confidence interval, the half-width of the confidence interval? It is, the half-width of the confidence interval is, anyone still remember? T alpha over 2, I multiply with all right. So the half-width of the confidence interval will depend on the number of replications. If you see in the report, the half-width say is correlated here, it means that the number of replication is not enough. Right? We didn't run a sufficient number of replications. So Arena is unable to calculate the half-width of confidence for us. Because if it calculate the half-width for us using this equation, the result is not accurate, right? So better give us the no result instead of give us the wrong result. Okay. Half-width is that when you see information like this one, you understand that the number of publication is not enough for the software to calculate the half-width of the confidence interval. We cannot estimate the confidence interval with too few number of publication. Let's check the entity one. Oh, no entity statistic available. I guess my one I didn't. I think I didn't check the run setup here. Yeah, I forget to check the statistic collection here, so that's why that category is not available. So later I check this one. I think for your case, you should be able to look at it, right? And compare with the previous report when we only run one replication. There should be difference in the result. Okay, class? Any questions so far? Okay, now let's learn something new. Any question? It's hard for me to know whether you have any question when we study online like this. So please don't hesitate just to type in any question you have in the chat box. Is it okay? Let me check the chat box. No, there's no. Let me see chat box. All right, no questions so far. Okay, so let's learn something new. Okay, I'm going to open the slide. This time I already show you how to do a simple animation with the station and route, right? Okay, so we can explore it more if you are interested in. Let's learn something more important here. Let me share. All right, we are learning about the entity transfer and using the modules in the advanced transfer panel. And this is particular necessary when you want to simulate a material handling system. So before we use the connection, right? We have on the module from module. Say, okay, so in our simulation module, entity go from one module to another module by using the connection like this one. So we assume that there's no delay in traveling. There's no time delay in traveling. All right. And also there's no limit number of transfer. Right? If we have many entities finished for the first process, it can immediately transfer to the next process. We don't limit the number in the transferring. So last week we learned how to use the station and route. So the station and route allow us to define different route for the entity. And in the route module, you also can define the time delay for the transfer. However, the route module doesn't tell us how many numbers of transfer can occur at the same time. And that would depend on the availability of the resource that we use for material handling. Okay, let's say we can only transfer one item at a time, or we can transfer 2 items at a time. We can transfer 10 boxes at a time. And we also don't talk about how many resource that we use for the material handling. Okay. So we don't we cannot define that information in the root model. So well, for the entity transfer, we can classify into 3 categories. Look at here. The first one, we can say we can call it resource constraint transfer. It means that the numbers of the entities that we can transfer would depend on the capacity of our resource. This one, like when we simulate a network link, we need to send a message information through a network link. And like if there's so many people use that network, they will be slowed down, right? Because there's some limit, some capacity limitation in the network link. So in that case, we need to define the capacity of our resource for the transferring. Now, the second type of material handling, okay, which is quite common, we call it transporter. Right. So we define this transporter as movable resource. The resource movable. When you think of an example, like when you use a forklift, okay, or you use a truck, or use a cart, right, or an AGV, you know, AGV. AGV stands for automatic guided vehicle. In some advanced system, they will use the automatic guided vehicle. So the vehicle will go in a fixed route. There's a rail for it. But the car and hand trucks or the forklift is kind of free parts. There's no fixed parts for it, so it can take any part in the factory or in the warehouse. Right. And both all of these type of transporter, they moving, and so depends on the availability of the forklift or the truck and so on. It limits the number of entities we can transfer at a time, and also it will affect on the delay time. For the first one, like the resource constraint transfer, we usually estimate the time delay. But for the transporter, the time delay depends on the distance that the transporter have to move. Okay, and also depends on the number of transporter we have. Right. Now the third material handling type, we call it conveyor. So you see the difference between the conveyor and transporter? The transporter is moving, right? But the conveyor is fixed. But a features of conveyor, important feature of the conveyor is the space availability on the conveyor. Right. So in many advanced warehouse, we also use conveyor. Or escalators is also one type of conveyor. Okay. So all right. So in this course, we will talk about the resource constraints transfer. Okay, and the transporter. We won't have time to talk about the conveyor, but there's also very detailed instruction how to use conveyor in Kelton's book. So in case that you need it in the future, then you can always refer to Kelton's book to see the example of using conveyor. And now we will try the first two, the resource constraints transfer and the transporter. We'll try the resource constraint transfer first. Okay, now we still use our small manufacturing system model, the model 7.1 that I sent you. But this time, we will modify it. Instead of just average the transfer time in the root module, like 2 minutes, okay, we will add more information that we will have the resource constraint transfer. So the transfer capacity is limited by 2. It means that each time we can transfer 2 at most, 2 entities at most, 2 parts at most. It means like our resource capacity is only 2. Each time we can only transfer 2, so our capacity is 2. Okay, how will we modify our model now? Our current model, we are using station and route, right? We have station, and then process module, and then route module. Okay, let's say this is station 1, process 1, route 1. And we have station 2, process 2, root 2. Now, we can modify our module with the information resource constraint by using the same module root and station, but we add the old module that we already learned, the seize and release. Like after the root, the root tells us that where to go. It just tells us where the entity will go. But we will add a seize modules here. Do you still remember what we can define the seize module? The seize module, we can define the resource we need, right? Seize what resource, right? So we can use a seize module after the root module, and in that module we will define the name of the resource we want to seize for transferring. And here our capacity is 2. Then we will go to the resource data module and define the capacity of this transferring resource 2. Right, that's simple. Right. So root, show where to go, and then C sees the resource for transferring. The capacity of this resource is 2. And then when it goes to station 2, when the entity goes to station 2, as indicated by the root, it reaches station 2, then we have to release the resource. Right, so in that case, after the station module, you can add the release module here. All right, and ask is to release the resource that we just see previously. You get it? This is one option. This is one option. Now, what is another option? Another option is to use a new modules. Okay. Now, instead of using the root and seize module, instead of using the root together with the seize module, tell where to go and which resource to see, we'll replace it with the leaf module. The leaf module itself will allow us to define this information. Okay. And instead of using the station and the release, station and release the resource, we will use the enter module. And the enter module allows us to define similar logic, similar activities. Right. So I would like you to go to the model 7.1 again and replace the root module with the leaf module. You can find the leaf module in the advanced transfer panel and replace the station module by the enter module. Okay, let's do that. Replace the root module with the leaf module and replace the station module with the enter module. for the first order release station, you just keep it the same, right? Because it's a starting one. And the last station, the exit system station, you also keep the same. You just replace other station with the enter. Let me share the screen with you. Share the new screen. Screen. All right, here we are. Okay, so everything look exactly the same. Okay, the first station, the other release station, you use the same. Okay, right, we use the same here. But then for the roots next to it, you replace the root by the leaf module, and you should see something like this one for leaf module. The start sequence. Okay, I'm opening the start sequence. So see something like this. Right, you can give it the same name like the root module, the previous one, right? Give it the name like start sequence. All right. Let's say we don't have any delay here. All right, just put it 0. Now, transfer out. The leaf define how we transfer the entity out. What kind of resource we need to use? Here we are simulate a resource constraint transfer. So we have 3 options here. C transporter, request transporter. No, we don't want to simulate a transporter here. Access conveyor, no, we don't want to simulate conveyor. We want to simulate a resource constraint here. So we will choose C resource. Right. So the priority is just like the priority in the process module. Just leave it here. So whenever we seize a resource, there will be a queue before it. When you see resource, then you will have a queue. So leave is a default name here. Now the resource type, you have 3 types of resource here. For you can use a resource, a set attribute, or expression, like just choose resource. You can type in a resource name here. Give any name you like. Let's say I put here the name is transfer. Right, so we need to see a resource name transfer. Okay, and then next, define the connect type. We have the root, connect, convey, and transport. In our case, we need to choose root. And we choose by sequence because we already defined the sequence for different parts. We choose by sequence. The move time, you can leave it. Transfer time, we already defined the transfer time in the variable. Okay. The delay here, let's say you want to simulate that there's certain delay time for loading, then you can define the delay time here. If there's none, then just leave it. Delay is the time for load-in activity. The move time is the moving time. All right. Give you a few minutes to complete this leaf module. Yeah. This is the leaf module. All right. You done? Okay. Now let's look at the station. Next station, like cell 1 station. Before the cell 1 station would be the station, but now we replace the station with the enter module. You can look for the enter module in the transfer process panel. Advanced transfer. Yeah, you see it. The enter. The enter process. So replace the station by the enter module. But you still can use the same name, right? You still can use the same name, so like cell 1 station. The same name for the station, like cell 1. We already defined this one in the station. Use the same name. Now the logic here is like how long we want to delay at this station for the unloading activity. You already the entity already transferred to this cell 1 station. But you need time for unloading, then you define here. If not, just leave it there. Okay. And after that, what we do? We have to release the resource. Okay. Then when transfer in, we will need to release the resource. Because previously we seize the resource. Now we have to release the resource, not the transporter conveyor. Resource type again is the resource, and you should tell what is the resource name you want to release. So if we give the name transfer in the root module, then here we choose transfer. We have many resources to choose transfer. Okay, it's simple for the enters module. Tell that release the resource, name transfer. Can you do that? All right. Now, we do similarly for other routes and stations. Cell 1 process, and next is route from cell 1. This one will also replaced by a leaf module. The same thing here, we can give the same name when we use for the root module, like root from cell 1. We need to see a resource name transfer. Okay, the connect type is root and the station type by sequence. And then we go to cell 3 station, replace the station by the enter module. Everything is exactly the same. So I leave it as your homework, okay, to complete the rest. Just replace these modules. Let me highlight this one. So you complete it as your homework here. This root by the leaf. This station by the enter. This root by leaf. The station by the enter module. Replace by leaf. Okay. All right. The other will keep the same. This station will be the same. This station will be the same. No need to change. And also remember that in your resource data module, the basic process, where's the resource data module? You will have a new resource here, name transfer, and choose the capacity too. Choose capacity 2 for the transfer resource. All right. Any question? Complete this one as your homework. Right, and okay, let's try about 10 more minutes, right, and then we will stop early. Okay, no need to take a break. Let me clear this one. No question? Okay. Now I'm going to show you how to simulate with a transporter. Let's open the transporter. Where is it? Okay, here. Okay, let's take the transporter simulation. Now let's say also the same manufacturing system, but now we use a transporter like a forklift, and this forklift is in the type 3 parts. We can move wherever we can, whatever path available in the system. It's not like the AGV where we have to define a fixed path. Okay. And the traveling time of our transporter will depend on the velocity of the transporter and the distance that it has to travel. So these are the activities happening at each station. We have to firstly request a transporter, like forklift. Then the transporter will transport our entity to the new station. And at the next station, we need to free our transporter. So you see that is very similar to the resource simulation previously, but here we have a new feature. It's the travel time. Depends on the velocity and distance. The previous one we just give estimated traveling time, but this one we have a traveling time depends on velocity and distance. So now how should we modify our model? We can use the same module, the leaf module and the enter module. The leaf module and the enter module. So, but again, if you don't want to use the leaf module and enter module, we also have different ways to simulate this one. Okay. For the resource, for the resource constraint simulation, we don't need to request a resource because it won't simulate the resource traveling back and forth between two stations. It doesn't simulate it. But for the transporter, the software will simulate how the transporter moves back and forth between the station. So if we don't want to use the leaf module, you can use this combination. In the advanced transfer panel, you can use a module named request. So this request module allows us to request a transporter. Okay. Now, after request a transporter will move to our station. Then we can use another module named delay. Right, this is the old module, right, to describe the delay time. Okay. And then we use the third module named transport in the advanced panel. This transport module allows us to define how the entity transport from where to where. Okay. Similarly, for the enter module, if you don't want to use the enter module, you can use the three modules combination. A station module. Okay, and after that, use the delay module to describe how long we need to delay at the station for unload delay activity, for examples. And then use the release module to release the transporter. The advantage of using the separate modules like this one is the flexibility. It's just like in the process module, we can choose different combination of logic like C delay release, or C delays, or delay release, or you can use three separate modules, C, delay, and release. So when you use separate modules like that one, you can, let's say, enter other modules in between if necessary. Let's say between the request and delay, then there are other things happen in these two activities. So you can add some modules between these two modules. between delay and delete, let's say there's some certain activities happening here. So you can insert other modules between these modules. That's the advantage. Else, we just use the leaf module. Just use the leaf module and the enter module. It will be sufficient. Right. So let's try it. Now you save your model 7.1. The one that we just did now, let's say it's 8.1, the one with resource constraint as model 8.1, and I will save it as a new file, model 8.2 for the transporter, and we modify this one. Okay, save the one that we just did for the resource constraint as a new file, so that we can modify with the new feature of transporter. Right, can you do that? Okay, now let's do it together. So here we have the old station. Now the previous one, suppose that we already changed the route into the leaf station. Okay, leaf station. Now this time you can try to put a delay time for loading process, for example, and in the transfer out. Just now we choose see resource, right? Now you choose request transporter. Request transporter, the transporter name. Okay, transporter name here. You can type in the transporter name here. Right. Now selection rule. Let's say if we have more than one transporter, then you have to tell Rena the rule which to choose the transporter. If we have more than one. So we have like a silicon, random, refer, other, and so on. Okay. So let's say we choose the rule of smallest distance. So the car which is nearest our station will be chosen. And let's say we also want to save that information, like which cars we use to transport our entity into the attribute of our entity name, name number, the card number. Okay, we already have many attributes here. Now we add one more attribute name, the card number, like this one. Okay, sorry. And for the connect type, just now we use root for the resource constraint, but now we will choose transport for the transporter, and the station type still by sequence. Okay, I give you 2 minutes to change the information here. In the leave module, choose request transporter. And keep in the transporter name. You can give any name, but let's say we choose a name card here. Selection rule, choose a rule that you like, but you can choose the smallest distance. Connect type, transport. And station type by sequence. Okay. Now let's go to the cell one station. This is supposed to be the enter one. The enter one. Okay, just leave the same name cell one station. Station name cell one. Here, the previous example we leave this one 0, right? This time you can put a value or you leave 0, it's okay. For the delay time for unloading activities, for example, okay, in the transferring, instead of releasing the resource, we will choose free the transporter. And also we need to tell what transporter name, the card, and which is the unit number if we have more than one card. Okay, give you 1 minute to change the information in the enter module. All right. You can check in the advanced transfer panel. Look at the transporter. Here you have a transporter name card. You type in the leaf module. Okay, so indicate how many cards we have. Just now the resource capacity we have 2, so here we also have 2 cards. Okay, the type we choose free pass. If it is an AGV automatic guided vehicle, then we choose guided pass. But now we use free pass. Okay, now this is a new one. You have to define the distance between the stations so that Arena can calculate the time for transferring the entity. So the time for transferring now would depend on the distance and the velocity of our transporter. We have to define these two. For the velocity, the default unit of time is minute. You could just leave it by default for minutes. But for the distance, the default unit of distance in Arena is feet. Remember, it is feet. So you have to convert everything to feet here. The velocity here means 50 feet per minute. Okay, so let's key in 50 feet per minute for our transporter. And we have to define the distance between the station in the distance set. The default name they give is the car dot distance. Right. Then the name of the transporter dot distance. So we need to define this distance set somewhere else. Okay. And this is the information we need to define for the distance set. Go back to okay, let me go back to the slide. Okay, let's say this is the distance between the cell station. We have the route from, we have the entity transfer from the first station named other release to cell 1 and cell 2. So we have the distance between the other release station to cell 1 is 37 feet. Remember, everything is in feet, is the default unit in Arena. From the other release station to cell 2 is 74 feet. We don't have any transportation from other release to cell 3 and cell 4. We don't have. So in our distance set, we no need to define this one. We do have the transportation from cell 1 to cell 2. The distance is 45. Okay, and we do have the cell 2 to cell 3 is 92. In short, we would have how many distance we need to define the set? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right. Okay, so you need to define this system. Okay. Let's look at the example. We go back to the arena now. Now let us go to the distant data module in the advanced transfer panel. And define the distance set. Right here is a peer name that we already put their card dot distance. And we have to define the rows here. Wow, in this example, I have more than 11 distance. It is because, let's say we have the distance between other relay stations. You can use the drop list, right? So that we can avoid making a mistake of typo error. From the other release to cell 1, the distance is 37. But let's say if in reality, when you transform back from cell 1 to other release, it takes another route and the distance is further. It's different. Then you can type in this one. You can add this information like cell 1 to other is 155. Or like we have cell other release to cell 2 is 74, but cell 2 to other release take another pass and it takes longer distance. In that case, we have to define it here. If not, you don't need to define. Okay, so define the distance between the station in the distant data module. And I leave this one as your homework. All right. Okay, now in short, what you need to do at home, you complete this model H42 by changing on the modify the information for the leave and enter station. Choose the transporter option. And you need to define the transporter with the velocity and the distance set, and then type in the information of the distance. Okay, that is your homework. You need to submit this model for me in 2 weeks time. The deadline is 2 weeks. Next week we will not have lab class. Okay, we will wait after 2 weeks and see if the COVID situation got any improvement. If there is, then hopefully we can have an offline lab after 2 weeks. But I will confirm with you about whether it is online or offline class after 2 weeks. Right. So that is the first homework. Now the second homework will be in Calton. Let me check the second homework. Give me a second. The second homework is from Calton's book. Sorry, give me some time. Chapter 8. Calton chapter 8. Hold on. Okay, Kelton chapter 8, exercise 8.8. This is the second homework. 8. Let's me type in here. Second homework is Kelton. All right. Chapter 8, exercise 8.8. Okay, deadline is also 2 week time. All right, class, any question? Okay, if there's no question, we stop early today. Okay. See you next week for the theory lab. Sorry, for the theory class. Very likely that next week is still online class for the theory, but next week we won't have the lab class. Okay, so spend the 2 weeks to do the homework. Okay, bye class. Oh, is it a question here? All right, see you next week online class. Bye.